Hi everyone, welcome back to Tech-Bimba channel. In the previous video, we talked about a synchronization and a monitor lock in Java. In the today's video, we are diving into inter-thread communication. Inter-thread communication is all about how dependent threads coordinate their execution. Let's try to understand this with a real-world example. We have a restaurant which serves the food on demand. Customer walks in and he is thinking what to order. Until customer places the order, cook has to wait. Once the cook places the order, cook will start preparing the food. While food is being prepared, customer has to wait. Once the food is ready, cook or a waiter will serve the food to the customer and customer enjoys the food. Think of a customer as a one thread and a cook as a one thread. Cook has to wait until customer places the order. After the order is being placed, customer has to wait until the food is being served to him. So if you note here, each thread's execution depends on each other's execution. This is where inter-thread communication will come into picture. In Java, inter-thread communication is achieved using the methods wait, notify, notifyAll. These methods acts on the monitor lock. In the previous video, we have seen what is monitor lock. Just to recap, once we create the object, JVM internally maintains the monitor lock for that object. The fundamental rule of monitor lock is once the monitor lock is acquired by any other thread, so other threads won't be able to acquire that. At any one point of a time, only one thread will be able to acquire the monitor lock on an object. Let's say we have a monitor lock on an object X and it is acquired by a thread T1. If other threads like a T2, T3, T4 are trying to acquire that monitor lock on object X, they won't be able to acquire that. Since monitor lock on object X is acquired by thread T1. Only once thread T1 releases the monitor lock on object X, then the threads those are waiting for a monitor lock on object X, they compete with each other. The thread which wins the race is the one going to acquire the monitor lock and it will proceed with its further execution. These methods also works on the monitor lock. This monitor lock is associated with the object. So considering this design decision, Java developers kept these methods as a part of an object class rather than the thread class. It is a very important question that why these are part of an object class rather than the thread class. Short answer is they act on the monitor lock and a monitor lock is associated with the object. In the design aspect, it makes sense that these methods to be a part of an object class rather than the thread class. Now let's see these methods one by one. Let's say we have a two threads, thread T1 and a thread T2. So they are sharing the object X. We have called the start method on these threads. Now thread T1 and T2 both are running. Let's say T1 got a CPU cycle. T1 will acquire the monitor lock on object X and it entered the synchronization block or a method. Then let's say there is a method call of a wait. So on calling the wait, T1 will release the monitor lock on object X and it will move to the waiting state, which means that T1 will now is waiting for the monitor lock on object X to proceed further with its execution. Now let's say after some time T2 got a CPU cycle, T2 will acquire the monitor lock on object X and enters the synchronized method. So in the synchronized method, if you call the notify, so then the thread T1 which is waiting for the object X will get the notify signal from the JVM. Then thread T1 moves from waiting state to a block state. So note that T1 is not moving to the runnable state. It is moving to the block state. The reason is T1 is still holding the lock on the object X. Only once T2 releases the monitor lock on object X, thread T1 will acquire the monitor lock on object X and it will resume its execution wherever it left out. Means it will start after the wait line. You might be wondering what if more than one thread are waiting for the monitor lock on object X. In that case, on calling the notify, JVM chooses any one of the thread and to that thread notify signal will be sent. That notified thread will be moved from waiting state to a block state. When thread T2 releases the monitor lock on object X, that notified thread will be able to acquire the monitor lock on object X and it will proceed further with its execution. The last one is a notify all. On calling the notify all the waiting thread on the object X will get the notify signal at the same time. All those threads will move from waiting to the block state. Once T2 releases the monitor lock on object X, the threads those are in a block state, they compete with each other. The thread which wins the race is the one going to acquire the monitor lock on object X and it will proceed further with its execution. This is how wait, notify all methods are related to each other. Now let's see the difference between wait method and a sleep method. Sleep method is a part of a thread class. Wait method is a part of a object class. On calling the sleep, it won't release the monitor lock, whereas on calling the wait, it releases the monitor lock. On calling a sleep, thread status will change to timed waiting state. On calling the wait, thread status will change to waiting state. If we have a requirement that we want currently executing thread to be interrupted for some duration, in that case we call the sleep method. For example, thread.sleep 2000, which means currently executing thread will be interrupted for 2 seconds. Once 2 seconds are elapsed, the thread which is in a timed waiting state because of a sleep method will move back to a runnable state. In case we have a requirement that currently executing threads execution depends on other threads execution, in that case, to leverage the inter-thread communication, we can use the wait method. Hope this is clear. What is the difference between sleep method and a wait method? Now let's see the classical producer-consumer problem. In this diagram, we can see that there are two threads, producer thread and a consumer thread. These threads are sharing the common resource, which is a shared buffer. Producer thread is the one that puts the data into the shared buffer. Consumer thread is the one that reads the data from the shared buffer. The key rule here is producer thread wait if the data is already present in the shared buffer. Consumer thread should wait if shared buffer is empty or shared buffer won't have any data. Now let's see the code, how producer consumer problem can be solved using the inter-thread communication. We have a class with a name shared buffer. The object of this class is being shared between the producer thread and a consumer thread. Then we have a two instance variable, is available and a data. Is available indicates that whether the data is available in the shared buffer or not. Data is the actual data or the value produced by the producer thread. Next we have a produce method and a consume method. Produce method is being called from the producer thread. Consume method is the one being called from the consumer thread. Producer thread produces the value. To accept that, produce method have a value or it is accepting the value of a type integer. Producer thread must wait until there is a data in the shared buffer. For that we are having this while loop. We are checking the value of is available. In case is available is true, we are entering into this while loop and we are calling the wait loop. This ensures that producer thread will be in a waiting state until there is a data in the shared buffer. In case is available is false, which means there is no data in the shared buffer, then whatever the data that producer has produced, right, that we are assigning into instance variable. Then we are printing the name of the thread, whatever the value we received from the producer thread, that we are printing here. Now shared buffer has a value because of which we are updating is available to true. Then we are calling notify all. On calling notify all, consumer thread receives the notify signal. It is the way producer thread is communicating with a consumer thread and it is saying that producer thread has produced the value into the shared buffer so that now consumer thread can wake up and it can consume that. On receiving the notify signal from the producer thread, consumer thread wakes up and it will acquire the lock on the shared object and it will enter into the consume method. Consumer thread has to wait until there is no data in the shared buffer. For that we are having this while loop. In case is available is false, then it will keep on entering into this while loop and it will call the wait method. This ensures that consumer methods keeps on waiting until there is no data in the shared buffer. In case there is a data, we are printing the name of the thread and whatever the value that is consumed by the consumer. Okay, now consumer consumed the value, right? Now there is no data in the shared buffer. For that, we are updating is available to false. Then we are calling notify all. On calling notify all, producer thread will get the notify signal. It is the way consumer thread is communicating with the producer thread. It is saying that it has consumed the value whatever producer thread has earlier produced. Now shared buffer is empty so that producer thread can wake up and produce a new value. Next we have a test class. Here we are having a public static void main method. We are creating the instance of shared buffer. Then there is a producer thread and a consumer thread. Producer thread runs a for loop 3 times. Within each iteration we are calling a produce method. We are passing the value of a I as a parameter to the produce method. After producing the value, producer thread will be interrupted for 1 second. Consumer thread also runs the for loop for 3 times. Within each iteration we are calling the consume method. After consuming a value, consumer thread will be interrupted for 1.5 seconds. At line number 33 we are calling producer.start. After that we are starting the consumer thread as well. Let's run and try to understand its output. So on running we are getting this output. Producer produced a value 1, consumer consumed a value 1, producer produced value 2, consumer consumed a same value which is 2, producer produced value 3, consumer consumed value 3. So if you note here, whatever the value producer has produced, the same value is being consumed by the consumer thread. None of the values are missed. Now let's try to understand how actually it is working. On calling producer.start, producer thread is ready to execute this lambda expression. On calling consumer.start, consumer thread is ready to execute this lambda expression. Let's say producer thread got a CPU lifecycle. It will start executing this lambda expression. So it is executing for loop. So value of I will be 1. 1 is less than or equal to 3, because of which it will execute line number 13. Buffer.produce and a value of I is now 1. Control will come to produce method. Value of data is 1 here. It won't execute because is available is a false, right? Data is set to this dot data, means this dot data value will be 1 now. Then we are having a system.println. Okay, here we are printing the name of the thread and whatever the value we received from the producer thread, because of which we are able to see this output in the console. Producer produced value 1. Producer produced a value 1 to the shared buffer, because of which is available is being updated to true. Then we are calling a notify all. This is where consumer thread will receive the notification or a notify signal, right? After producing a value, producer thread will be interrupted for 1 second. Consumer thread will wake up. Okay, it will get a CPU cycle. So it will start with a for loop. Value of I will be 1. 1 is less than or equal to 3, because of which line number 25 will be executed. Buffer.consume will be called. Consumer thread will acquire the lock on the shared buffer. Okay, this won't execute because is available is true. We are having a system.println. We are printing the name of the thread and whatever the value being consumed by the consumer thread. So we can see this output, consumer consumed value 1. Now there is no data in the shared buffer. So we are updating is available to false. Then we are calling a notify all. So now producer thread will get a notify signal. After consuming the value, consumer thread will be interrupted for 1.5 seconds. Producer thread will get a CPU cycle. It will start its execution from wherever it has left out. Value of I will be updated to 2 now. 2 is less than or equal to 3, so condition is true, because of which line number 13 will be executed. Buffer dot produce with a value 2 will be called. Now control will come to produce, but before entering to the produce method, producer thread will acquire the monitor lock on a shared object, that is shared buffer. This won't execute. 2 will be copied to instance variable. Then we are printing the value, that is we are printing the name of the thread. So because of which we are able to see this output. Producer produced the value 2. Okay. Next, we are basically changing is available to true. Then we are calling a notify all. On calling notify all, consumer thread gets the notify signal. Producer will be interrupted for 1 second. Consumer wakes up and in value of I will be incremented to 2 here. 2 is less than or equal to 3. So line number 25 will be executed. So consumer thread will acquire a lock on a shared buffer. This won't execute because is available is true. Okay, this line will be printed, because of which we are able to see this line on the console. This is how producer and a consumer thread interacts with each other using a wait and notify. Hope this is clear how producer consumer problem is solved using an inter-thread communication by leveraging the wait and notify methods. You might be wondering why we are using a while loop here, why we can't use a if condition. That is a very important intro question. Let's see what will happen if you use a if condition instead of a while loop here, right? So we are having a consume method here, we are having a if condition instead of a while loop here. We are checking is available inside a if condition here. Okay, let's say we are having a one producer thread, that is T1, then two consumer threads T2 and T3. We have started all the threads. Okay, let's say T2 got a CPU cycle, available is false, because of which T2 will move to waiting state. Now let's say T3 got a CPU cycle, still available is a false, because of which T3 will go to waiting state. Now let's say T1 got a CPU cycle, it produces the data say 10 into the shared object. Okay, after that it called a notify all, because of which T2 and T3 got a notify signal. Okay, let's say T2 got a CPU cycle, it will start from wherever it has left out, means it will print the line data, right, consumed data, so which is 10. Okay, available will be set to false because T2 consumed the data. Then we are calling a notify. Until this one everything is fine. Let's say T3 got a CPU cycle, T3 will start from wherever it has left. Okay, T3 will also print the same line, consumed data as a 10. This is wrong, right? Because value 10 is already consumed by thread T2. Okay, if you note here, we are printing the value that is already consumed by thread T2. Okay, to avoid that we have to use the while loop. In case here if you have a while loop, right, so once T3 will get a CPU cycle, it will check the available in a while loop. So available is now false. Okay, because thread T2 updated available to false. Now since available is a false, control will enter into the while loop and T3 will be in a waiting state till available is true. Because of which we should always use the while loop to avoid a false notify signals to the threads. And the reason is sometimes even a thread will wake up because of a operating system's spurious wake up. So JVM developers has basically used the operating system thread scheduler itself for the managing the threads. So operating system thread scheduler might wake up the thread even though it is in a waiting state. It will wake up the thread scheduler maybe because of optimization, memory reordering, or a signal handling, or even for a race resolution. In that case, if you have not used the while loop, if you are using the if condition, then again we end up with basically consuming the wrong data. So it is always recommended to use the while loop to avoid such a consumption of a wrong data, okay, or a inconsistent behavior. And one more thing we need to understand that if you notice that we are calling wait, notify all methods within the synchronized method, it is very important to call these methods inside the synchronized method itself, because wait, notify all method works on the monitor lock, and synchronized methods or synchronized blocks are the only way to acquire the monitor lock. For this reason, it is always better, or it is always recommended to call wait, notify all methods within the synchronized method or inside the synchronized blocks. So that's it for the today's video. If you found this video is helpful, please like, share and subscribe to the channel. In the next video, we'll be talking about a blocking queue. See you in the next video. Thanks for watching.